Cache patterns. So by now you have fallen in love with caching. You have got a fast little memory box sitting in front of your slow database and life is good. Reads are quick. Your database is breathing easy. You feel like genius and then reality walks in and taps you on the shoulder. Because here is the thing nobody warned you about. A cache and a database are now two separate places that both hold your data. Two copies of the truth. And the moment you have two copies of anything, a very annoying question appears and it refuses to go away. Okay, but who actually fills this cache? And when someone changes the data, who keeps these two copies in sync? Think about it. A user requests their profile. Does the app look in the cache first or does the cache magically know to fetch it? When that same user updates their profile photo, do you write the new photo to the cache, to the database, to both, in what orders? And what happens if you write to one but the app crashes before it writes to the other? Now your cache says one thing and your database says another, and your user is staring at a photo they deleted last week. This is the part of caching that quietly breaks real system, not the idea of cache. That's simple. It's the coordination. Two stores, one source of truth, a constant stream of read and writes flying in, and no clear rulebook for who does what. If you don't decide this on purpose, you end up with a tangled mess. Some parts of your code write to the cache, some don't. Some reads go around it. Stale data leaks out, bugs appears that only happen on Tuesday at 3 p.m. and you can never reproduce them. It's a pure chaos. So the problem isn't how do I build cache. You already know that. The problem is who is responsible for filling the cache and keeping reads and writes in sync. And what are the exact rules? Now let's understand how the idea of cache patterns solves it. So one day engineers got tired of every team inventing their own messy, half-broken approach to this, and someone asked the obvious question. What if we just agreed on a few standard rule books for how the app, the cache and the database talk to each other? Then everyone knows exactly who does what. That's all a cache pattern. A cache pattern is just a standard rulebook that says who reads where, who writes where, and in what order. So your cache and your database stays in sync without chaos. Let me give you the analogy we are going to write for this entire video because it makes every single pattern click. Imagine you hire a personal assistant. This assistant has two things on their desk. First, a small notebook they keep right in front of them. Quick to flip often, quick to scribble in. That notebook is your cache. Second, behind them, there's a giant filing cabinet. The big, official, organized archive where every record truly lives. That filing cabinet is your database. Now the notebook is fast but small. The filing cabinet is slow but holds everything and never loses anything. Your assistant's whole job is to answer your question and record your changes using these two tools. But here is the catch. How should the assistant use them? When you ask for a file, should the assistant check the notebook first or always run to the cabinet? When you hand them a new document, should they jot it in the notebook, file it in the cabinet, or both, and in what order? Each different set of rules you could give your assistant is a cache pattern. That's it. Same notebook, same cabinet, different instruction, and the magic is the rules for reading are separate decisions from the rules for writing. So let's split them exactly that way. What exactly is cache pattern? Let's make it concrete. A cache pattern is a defined strategy for how three players interact. Your application, the code, your cache, the fast notebook, and your database, the slow filing cabinet. The pattern answers two big questions. On a read, who checks the cache? And who goes to the database when the cache doesn't have the answer? And on write, where does the new data go first and how does it reach both the cache and the database? That's the key insights to hold on to. Reads and writes are two separate problems. You pick a rule book for reading and you pick a rule book for writing. They are chosen independently. There are 5 patterns you need to know. 2 of them about reading. Cache aside, also called lazy loading, read through. And 3 of them are about writing. Write through, write back, also called as right behind and right around. Don't worry about memorizing the list. By the end, each one will just feel like a sensible instruction you would give your assistant. The first reading pattern is cache aside, lazy loading. This is the most common one in the world, so really feel it. In cache aside, the application is in charge. The cache is just a dumb storage box that knows nothing about the database. Here's the assistant version. You ask for a file. Your assistant flip open the notebook first. If it's there, great. Hand it to you instantly. That's a cache hit. If it's not in the notebook, a cache miss. The assistant walk into the filing cabinet, pull the file, hand it to you, and then scribble a copy into a notebook so next time it's right there. The assistant is the one doing all the deciding. The notebook never talks to the cabinet directly. Step by step in real time. App needs data. App checks the cache. Cache hit, return it. Done. Cache miss. App goes to the database, gets the data, return it to the user and writes a copy into a cache for next time. The beautiful thing, the cache only ever holds data that someone actually asked for. Nothing is loaded just in case. That's why it's called lazy loading. It only does the work when it's truly needed. The cache, the very first request for any piece of data, is always a miss. Someone always pays the slow price first to warm up the notebook. Second reading pattern is read through. Read through is almost the same picture with one difference. The cache itself is smart and does the fetching. In this version, your assistant doesn't manage two tools. Instead, imagine the notebook is a magic. You ask the notebook for a file. If it's written there, you get it instantly. If it's not, the notebook itself quietly walks to the filing cabinet, grab the file, write itself a copy and hand it to you, all without you lifting a finger. In real time, app asks the cache for the data. That's it. The app talks to the cache and only the cache. On a hit, cache returns it. On miss, the cache library goes to the database, loads the data, store it and return it. The difference from cache aside is who does the work on cache miss. In cache aside, your application code does it. In read through, the caching system does it for you behind the scene. Your app code gets cleaner. It just asks for data and trusts the cache to handle the rest. The trade is that you need a caching tool that actually supports this. You can't bolt it onto just anything. So that's the read side. Cache aside, the app is the boss. Read through, the cache is the boss. Now the write side. The writing pattern first is write through. Now your user changes something, a new profile photo. Where does it go? In a write through, the rule is simple and strict. Every write goes through the cache and the database together at the same time before you say done. Your assistant takes a new document and in one motion scribble it on the notebook and files it in the cabinet. They don't tell you saved until both are updated synchronously, no shortcuts. In real time, app writes the new data to the cache. App writes the same data to the database. Only after both succeed do we call the write complete. The payoff, the notebook and the cabinet are always in agreement. Your cache is never stale because every change hits it the instant it happens. Read after a write are always fresh and fast. The cost, writes are slower because you are doing two writes instead of one and waiting for both. You pay a little time on every single write to guarantee freshness. Second writing pattern is write back or write behind. Write back is the speed demon. Here, you write to the cache first and tell the user done immediately, then flush to the database later in batches. Your assistant takes your new document, scribble it into the notebook and instantly say, got it. You walk away happy. The cabinet isn't been touched yet. Later, maybe every few seconds or once 100 changes piles up, the assistant gather all those notebooks, scribbles and file them into the cabinet in one efficient trip. In real time, app writes to the cache. Cache says done right away. The user isn't waiting. Later, the cache flushes the accumulated writes to the database, often grouped together. The payoff, write feel instant. And the batching means far fewer trips to the slow database. This is fantastic when you have a flood of writes. The cost, And this one is serious. If the cache dies before it flushes, those writes are gone. The cabinet never got them. They lived only in the notebook and the notebook just got wiped. That's a real data loss. Writes back trades safety for raw speed. Writing pattern 3, write around. Write around takes the opposite stance from write through. Here, the write goes straight to the database. Skip the cache entirely. The cache only gets filled later on a read. Your assistant files a new document directly into cabinet and does not write it to the notebook. The notebook only gets that entry if and when someone actually asks for it later. At which point your normal read pattern kicks in and pulls it in. In real time, app writes the new data straight to the database. The cache is not touched. Often, if an old copy of that key exists in the cache, you delete it so it can't go stale. The data only enters the cache the next time someone reads it. The payoff? You don't clog up your precious notebook with the data nobody going to read soon. Imagine logging millions of events that almost never get read back. Why fill your fast little cache with all that? Write around keeps the cache clean and reserved for stuff people actually request. The cost? If someone does read freshly written data right away, it will be a cache miss. They pay the slow price. Write around bets that recently written data won't be read again soon. For now, hold this whole map in your head. 2 read rules, app driven or cache driven. 3 write rules, write to both, write to cache then flush, or write around the cache. Mix and match the read rule and the write rule your app actually needs. Now what are the trade-offs of using it? Cache aside gives you simplicity and cache that only holds what's wanted, but every first request is a slow and you have to remember to update and delete the cache yourself when the data changes or you will serve stale copies. Read through gives you cleaner app code, but you are now dependent on the caching system that supports it and you have less direct control over the fetch logic. Write through gives you a cache that always fresh, but you pay extra time on every write. If your app writes a lot, that adds up. Write back gives you a blazing fast write, but it dangles the risk of real data loss if the cache crashes before flushing. You are trusting a fast, volatile box with data that hasn't been safely filed yet. Write around keeps your cache clean, but punishes anyone who reads data right after it's written with the guaranteed miss. The deep trade running through all of them is the same one from caching itself. Freshness versus speed and the safety versus speed. Each pattern just picks a different point on those two sliders. There is no best pattern. There is only the best pattern for your situation. Now when to use it? Use cache aside when you want a safe, general purpose default. It works with almost any cache. It only stores what actually requested and your system keeps running even if the cache goes down. The app just fallbacks to the database when in doubt. This is where most teams start. Use read through when you want your application code to stay clean and simple. You are using a caching tool that supports fetching data for you. Great when you have many places in your code that reads the same kind of data and you don't want to repeat the check cache, then check database logic everywhere. Use write through when freshness matter and you can't tolerate stale read after a write. It pairs beautifully with read through, good for data that read very soon after it's written, where serving an old copy would be wrong. Use write back when you have a heavy storm of writes and you need them to be fast and you can tolerate a small risk of losing the most recent changes. Think high volume counters, metrics and activity log where speed beats perfect durability. Use write around when the data you are writing is unlikely to be read again soon. Logs, archival records, audit trails, write them straight to the database and don't waste cache space on data nobody about to request. So what are the common mistakes? So first mistake is forgetting to invalidate the cache on writes with cache aside. Second is confusing cache aside and read through. Then reaching for write back without respecting the risk. Next is treating write pattern and read pattern as a one choice. Next is caching data that's written by write around and then immediately reading it. These are the common mistakes. Now few important interview questions. What is the difference between cache aside and read through? Walk me through what happens on a cache miss in cache aside. Compare write through and write back. When would you use write around and why? How do you keep your cache and database in sync? What is the biggest risk of write back? Can you combine these patterns? So a quick recap is a cache pattern is just a rule book. Read and writes are separate choices. There is no best pattern, only the best one for your situation. So that's all in this today's session. See you in the next one.